Okay, well, let's start with something that's not too tricky. Let's go with the GCSE idea of ionic bonding. Now, ionic bonding happens between a metal and a non-metal. So I've drawn any metal you like. It doesn't really matter how this works. We're just explaining how it works. So I'm using M for metal, and I'm using X for any particular non-metal you like. So it doesn't matter which non-metal you pick. This will work for all of them. If you look in the metal, you have an extra electron, which if you lose it, the metal will have a complete outer shell because it will go to the next shell in. And it can transfer it to a non-metal, which has got more than, say, 5, 6 electrons, and it's very easy for it to gain the electron from the metal to get to 8. If it takes the electron from the metal, you can see that it now has a complete outer shell. The metal has lost an electron, and because it's lost an electron, and electrons carry a negative charge, the positive nucleus isn't balanced anymore with the same amount of electrons. There's an imbalance in charge. There's more positives in the nucleus. You've taken a negative electron away. So overall, this atom has gained a positive charge because of the absence of the negative electron that's been lost to the non-metal. We now have to call it an ion. This is a positive ion, and you can see the positive here, and that's the symbol we give it, just to show you that overall it's got a positive charge. The non-metal, if you put it in the square brackets, has also got a negative charge because it's gained a negative electron. That means that the charge balance between the positive nucleus and the electrons around the atom have become overall one more negative particle than there are positive particles in the nucleus. Overall, this is a negative ion. You can see the charge here. Now you can see that up there. That tells you the charge on the ion. Now, positive ions are given the name cations, and negative ions are given the name anions. Now you can remember cation because the T forms a little positive sign. We digress. Now, what do we know about opposite charges? Opposite charges attract each other. So you're going to have a force pulling the positive ion towards the negative ion, and vice versa. You'll have the negative ion pulling towards the positive ion because these opposite charges are trying to get near to each other. And that force is what draws the ions together and is the definition of ionic bonding. This force here between the oppositely charged ions, plus and minus, is called ionic bonding and is defined as the electrostatic attraction between oppositely charged ions. You'll be asked during the exam to define what ionic bonding is, how it happens, and relate ionic bonding to the properties of the substances that are created. The plus and the minus create the force. That is an ionic bond, defined as the electrostatic attraction between oppositely charged ions. Now, during a chemical reaction, you're not just going to create one pair of ions, are you? You're going to have millions of particles all colliding, all creating these positive and negative ions. Now, that means they want to get as far away from the like charges of each other and as close to opposite charges as they can. So they arrange themselves plus, minus, and the pluses will go to as many minuses as they can, the minuses will get as next to as many pluses as they can, and they'll make this alternating structure. Can you see? So the positives are away from the positives, the negatives are away from the negatives, and the opposite charges are next to each other. Now remember, if you want to talk about the properties, it's good to remember that this happens in 3 dimensions. There are many strong ionic bonds. The structure is going to create itself in 3 dimensions. The positives are going to go next to the negatives in this lattice work. But remember, when you've got these millions of particles all coming together, they will form behind and in front as well. So you'll end up with a 3-dimensional structure. just like this. You'll have positives and negatives going behind as well. The negatives will go behind the positives, positives will go behind the negatives, and they'll alternate backwards as well as side by side. This is how crystals build themselves up. They line the oppositely charged ions next to each other to get the most stable configuration. Now these many strong bonds means that they're going to have a high melting point and a high boiling point. Because you're going to have to put a lot of energy into these many strong ionic bonds in order to break them. You might also be asked, can they conduct electricity? Now, as long as they're free to move, yes, they can. Now, if they're locked in a lattice structure, then they can't. So if they're in a solid form, they can't conduct electricity. But if you melt them or you dissolve them, then the particles become free, don't they? The ions become free to conduct the charge. And that is how they conduct electricity. If they're a solid, they can't. Because they can't move. Now let's see how we can create formula for ionic compounds. Look at your periodic table. Group 1 has got one electron in the outer shell. Group 2 has 2 electrons in the outer shell. Group 3, okay, you get the idea. When you get to group 7, there are 7 electrons in the outer shell. Now it becomes easier for them to gain electrons to get to a complete outer shell rather than lose them, so the non-metals like to gain. And this helps you predict how many electrons they need to gain. 7 just needs to gain 1 more to get to 8, and 2 electrons is easier to lose 2 to get to the next shell in, to get to the full shell. Group 1, well that's really easy, just has to lose that 1 electron, so you can predict what they need for their outer shell by looking at their group in the periodic table. Let's pick any group 1 metal. Let's say lithium. Lithium's in group 1, so it's got 1 electron to lose. If you look at any group 7, for example fluorine, fluorine wants to gain an electron. It doesn't matter which one it is. Let me do that again. Fluorine, and give it an electron, that will give it a full outer shell, and that'll create a fluoride ion. The only problem is, what if you get a group 2? Group 2 need 2 electrons in their outer shell. They form a 2+ ion. So a calcium ion has lost 2 electrons to get its full outer shell. Well, that gives you a problem, because if you react that with, say, fluorine, which wants to create a fluoride ion by just gaining 1 more electron, then how can you solve that? Well, why don't you just have 2 fluorides? If you have 2 fluorides, then you will counteract the charge created by the 2+ with the 2 minuses from the fluorides, 1 from each, and you will end up with a formula calcium fluoride, CaF2. Easy, isn't it? If you want to be really clever, you could write the equation. Let's try writing the equation. Remember, calcium's a solid, it's a metal. Fluorine is a gas, and it's always diatomic, F2. That will be handy in balancing it later. Your formula for it is CaF2. You worked that out earlier. There it is. Remember, these are going to have high melting and boiling points. That's how I know it's a solid. And there's the formula there. Let's just see if it's balanced. There's 1 calcium, 2 fluorines that side. There's 1 calcium this side, and 2 fluorines that side. So yes, it does balance. There are some odd or unusual ions which you're just going to have to remember. You're going to have to remember the hold on a second, let me undo that. The odd ones out. These are ones that you're going to have to commit to memory. You've got the hydroxide ion, forms a 1-. The carbonate ion, CO3 2-. You've also got the nitrate ion, NO3 minus, the ammonium ion, that is NH4 plus. It's not ammonia. Ammonia is a different compound. Remember, ammonium has an extra M and it has an extra hydrogen. It's a simple way of remembering it. When you come to cancelling out these ions, you use exactly the same rules as before. Oh, and don't forget there's sulfate as well, SO4 2 minus. Sorry, I'll just write that in. You have to do exactly the same rules. You get your sodium, and let's look at sodium sulfate. Sulfate forms a 2 minus, sodium forms a 1 plus. So the formula for this, you'll need 2 positives to counteract the 2 negatives. So the formula will be Na2SO4. Now, it's unlikely you'll be asked this in the exam, but it's always good to know how it comes about. Thanks for watching.